For question A, describe the arrangement of a Ventury meter and explain its mode of action.
Very good evening to our lecturer and to our friend. Today I would like to explain about Ventury meter in chapter 3. Okay, this is a part 9. Okay, this is part 1. Okay, part 1 is about entry. Okay, part 2 is cone. For the third part is throat. Okay, for the cone is they have an angle is 21 degrees. Okay, this part, this is a divergent. They have 5 to 7 degrees. Okay, this is convergent and this is divergent.
Question B. Derive an expression for the theoretical discharge through a horizontal Ventury meter and show how it must be modified to obtain the actual discharge.
Z1 plus V1 square over 2G plus P1 over rho G is equal to Z2 plus V2 square over 2G plus P2 over rho G. We can cancel out this, and P1 minus P2 over rho G is equal to V2 square minus V1 square over 2G. Q1 is equal to Q2. A1 V1 is equal to A2 V2. So A1 V1 over A2 is equal to V2. P1 minus P2 over rho G 2G is equal to A1 square over A2 square minus 1 multiplied by V1 square. For V1 is equal to A2 over A1 square minus A2 square multiplied by 2G P1 minus P2 over rho G. We know that this is H. So we substitute into equation where V1 is equal to A2 over A1 square minus A2 square 2G. This is just equation. We need to verify the V1. So V1 is equal to A1 A2 over A1 square minus A2 square multiplied by 2GH. We know that M is equal to A1 over A2. So we substitute into these equations. We got the Q is equal to A1 by 2GH over M square minus 1. Actual discharge is CD multiplied by Q, where CD A1 2GH over M square minus 1.
To taper from 300 meter in diameter at the entrance to 100 millimeter in diameter at the throat, and the discharge coefficient is 0.98. A differential mercury in U-tube cock is connected between pressure tapping at the entrance and the throat. If the meter is used to measure the flow of the water and the water fills the leads to U-tube and its contact with the mercury, calculate the discharge when the difference of level is U-tube is 55.
Given, the value for actual discharge is 0.98, diameter 1 0.3 meter, area 1 is 12 meter square, A2 4 meter square, X is the difference of the water in the U-tube, which is 0.055 meter. And from this equation, we can make one equation which is pressure 1 minus pressure 2 equals to X rho M minus rho multiplied by G, and we can make another one equation which is head pressure 1 minus pressure 2 over rho per G equals to X rho M over rho minus 1. We multiply 0.055 meter with 12.6, which is the pressure difference in the Ventury meter. And this is the value, 0.693 meter. For area 1, we multiply quarter by D1 square, and we insert the value 0.3, and this the answer, 0.0706 meter square. To know the value of area ratio M, we know that area 1 over A2 is equal to D1 square over D2 square. Insert the value 12 over 4 and 9 is this equation. We can insert all the value, which is 0.98 multiplied with 0.0706 square root 2 multiplied with 9.81 multiplied with 0.693 over 9 square minus 1. From this equation, we can find the actual discharge, which is 0.0285 meter cube per second.